Namaste. I'm Andrew, and today I would like to teach you how to use the remainder theorem to find the remainder of this polynomial division. So, what is the remainder theorem? It basically says that if you have a function f of x, in this problem, this is f of x, divided then by some linear function, you got to call it x minus k. Now, even if this doesn't have a minus sign, you still have to use this model x minus k, all right? It doesn't have to be a k, it could be an a or a c or a j, it doesn't make a difference. But you do have to use it like this. It has to be x minus some constant. And if you have this type of a setup, all right, where you have a function divided by some linear function, the remainder of this process will be equal to the function's value evaluated at k. So the goal is that you got to find out what k is. So k comes from the divisor, or from this linear function that's going to be in the denominator. All right, it's always to the right-hand side of that division symbol here if you have it in this form. So what I'm going to do is I'm just going to write x minus k, and this one's really simple because the x's line up, the negatives line up, and therefore 3 is k. I mean, this is nice and easy. All right, so k is equal to 3. I wrote an x. K is going to be equal to 3. All right. But what happens if this were a positive sign? Well, I have other videos on that, but I think this other method I'm going to show you very quickly, works a lot better. I would just do it this way personally. Actually, I do it this way. So x minus 3, set that bad boy equal to 0, solve it for x. Okay, so you got to add 3 to both sides. And then whatever this works out to be is your value of k. All right, it's not that x is equal to 3, but it's really, this is k. All right, so mathematically speaking, it shouldn't, I mean, it is x equals 3, but this has some other meaning. It is k. All right, so as you notice, we came up with the same conclusion that k is going to be equal to 3. The benefit of this method is that, if you have a coefficient here like 7, you can still use this method. And then your k value would have been 3 over 7. All right. Yeah, it's just, I think it's a lot better. Anyway, now the whole thing is of the remainder theorem. There we go. Couldn't really get that one out, but finally did. The whole idea here of the remainder theorem is that once you find the value of k, you can plug that into your function everywhere you see x and just evaluate it, in other words, meaning just solve it then. All right. So we're going to take everywhere we see x, plug in your value of k. So k was 3, so plug in the 3 there. It's cubed. Plus then 4 times 3, that's going to be squared, minus 8 times 3, plus 2. Now all you have to do is just solve this. I'm going to use the calculator quickly. So I got a value of 95. Class of 95. What movie? If you know what movie, that's pretty sweet. I used to love that movie. Yes, I have no friends. So anyway, what we're going to do, what we're going to do is we're done. That's what we're going to do. We found the remainder, right? The remainder then is going to be 95. So that's the benefit of this method. It's kind of short and sweet, right to the point. You can plug it in then once you find k into your function, bada bing, bada boom, and you found your remainder. All right. Another way to do it is to use synthetic division. I'm going to do it quickly on this problem just to kind of show you that the remainder does work out to be 95. But it's also beneficial in case you, forget the remainder theorem. You have another way to do it. Take a look. Bam. So the number of columns here in my synthetic division table, which I have 4, is going to equal the highest power of x added 1 to it, so 4, okay? So what goes here now is the coefficient of your x cubed, your x squared, your x term, and then your constant. So the coefficient of the x cubed term is a 3, the coefficient of the x squared is a 4, coefficient of the x is a -8, and your constant is a +2. Then, to find the value that goes on the outside here of the table, you're simply going to take your divisor, set that equal to 0, and solve it for x. Interesting, right? Interesting, because guess what? This is the same method we employed before, right? So this is going to be, what kind of a number is that? I don't know. It's a new. Actually, kind of looks like a face a little bit, right? Here's the mouth. Right? I don't know. What do you think this looks like? Okay, x is equal to 3. So this is the value that's going to be plugged into the outside now. So what you're going to do is you're going to drop down the first value, 3. You're going to follow this series of steps. Take the bottom number, multiply it by the outside number, so that's a total of 9. Plug it into the next adjacent cell there, and add this on up. So that should be 13. Then what you're going to do is you're going to take this value, still multiply it by that outside value, so that should be 39. Plug it into the next adjacent cell, and add that on up. So when you add this on up, right, so that should be a positive 31. Then what you're going to do is you're going to take 31, multiply it by the 3, and that should then be 93. Then you're going to add this on up, and OMG 95. There's your remainder. Thanks for tuning in, ladies and gentlemen. I really do appreciate it very much. I do hope this helps. I hope you see multiple ways to do it. And if you don't mind, like, subscribe, maybe even tell some of your classmates. That's really the best way to support us, right? We don't really ask for anything except for just help us spread the word. All right? And by the way, check out our channel because we have amazing resources. We have thousands of videos out there, not only in math, but chemistry and physics as well. And we have a lot more coming. We solve specific problems. We really try to help you out in terms of problem solving because guess what you're going to see on your test? Problems. Check us out. We'll see you soon.